Have you ever wondered what a star sounds like when it rests? Not when it burns or flares, but when it simply glows quietly, endlessly, in the dark? The night holds that kind of silence now. Your breath matches it, slow and even, like a tide that forgot to hurry. Somewhere beyond the hush of our world, a single star exhales light, and space itself seems to breathe with it. Its glow drifts through clouds of dust and time, soft as a sigh across the fabric of the sky. Inside those veils, new beginnings gather tiny sparks learning how to shine. The universe isn't loud when it creates. It hums, it waits. And if this soft journey brings you rest, a gentle like and a quiet subscribe, help others find their way to this stillness too, only when it feels right. For now, loosen your shoulders, close your eyes. We'll begin together, unhurried and warm. What does it mean for a star to have a life? From far away, it looks simple, a familiar light arriving each night, steady as breath. But steadiness can hide a long, quiet drama. A star is not a fixed pin in the dark. It is a story unfolding. It is born from cold shadow, grows into warmth, changes its face with age, and in the end, returns its riches to the night. The carbon folded into your cells, the oxygen that slides in and out with every gentle inhale, the iron moving through your blood like soft compass filings, all of it once lived inside a star that burned and ended before our sun learned its name. To trace a star's life is to trace the long history of everything that feels like home. Galaxies curving like rivers, the stones of planets, the salt of oceans, the green weight of forests, and you sitting here in the hush. Creation moves slowly, but it does not stop. The pace suits the night. We follow without haste, the way a tide follows the moon. The path begins where light hardly goes, in places so dark that the dark itself seems thick. These are the molecular clouds, the great nurseries. Not little wisps, not stray puffs, but continents of shadow. Some stretch for dozens, even hundreds of light years, their bodies stitched from hydrogen and helium with a dusting of heavier grains. From afar they look like silhouettes cut into the Milky Way, horseheads and eagles, long veils and upright pillars, shapes born from chance that feel oddly familiar to the human eye. Through a telescope their edges glow where nearby starlight brushes them, and we give them names because it's human to name what we love. Inside, the feeling changes. Imagine drifting through a space so spare that you could cross billions of miles before bumping a single atom, and yet so large that the total mass could build not one star, but thousands. A single cloud can cradle the weight of 1,000,000 suns. It is cold here, one of the coldest kinds of cold. The universe knows only a few dozen degrees above absolute zero. At such temperatures, atoms move like careful sleepers, and hydrogen prefers company. Two atoms settle into a pair and become molecular hydrogen. That pairing gives the cloud its name and its quiet. The dust helps too. Tiny grains of carbon and silicate, no bigger than smoke, float everywhere like a fine ash from an ancient fire. They soak up harsh light, scatter what would intrude, and turn the cloud's heart into a dim refuge. Without that dusty curtain, the glare of nearby stars would peel the cradle open before anything could begin. Gravity works here the way patience works in a long winter. It does not shout, it does not hurry. It keeps choosing the same direction. A nudge from far away, a past supernova's ripple, a passing spiral arm's squeeze, the slow pull of two galaxies brushing disturbs the quiet just enough. Tiny pockets grow slightly denser than their neighbors, Those pockets call to more gas. The more they gather, the louder the call becomes. It's a gentle feedback that becomes a habit, then a hunger. From where we stand, nothing seems to move. But instruments tuned beyond human sight pick up the faint signals. Radio telescopes listen to carbon monoxide, ammonia, and simple organics whispering their presence. Infrared eyes feel warmth that visible light can't carry out. In the dark where stars begin, chemistry is already sketching futures, small rehearsals for later lives, where water will pool and carbon will braid itself into memory. The picture that lives in many minds is a photograph, the pillars of creation in the Eagle Nebula, that towering garden of gas and dust. The pillars rise for light years, long fingers reaching into their own night. At their tips, newborn stars are turning on, their first light nibbling caves into the shroud around them. The image is so calm you might forget the currents hidden inside, but even calm things move. Turbulence sighs through the columns. Shock waves skate their flanks. Gravity keeps weighing possibilities and saying yes. Dust is the quiet accomplice. It turns down the volume of starlight. It keeps the fragile places safe, long enough for change to take root. Every grain is a little sail, a little shield, a little ember from past generations of stars. We owe it tenderness for that. In its shadow, hydrogen can linger, cool, and gather. Protected, the cloud begins to fold into itself. The folding is not a fall off a cliff. It is a long, unending exhale toward a center that didn't exist until the folding began. Each hydrogen molecule feels a tug from everywhere at once. But where there is slightly more, the tug is slightly stronger. Those slight differences grow. Knots become clumps. Clumps swell and fragment, each fragment preparing a future of its own. As matter drifts inward, it trades height for heat. The energy stored in being spread out, the potential to fall spills into motion. Collisions between particles grow more frequent, more insistent. Warmth returns in a place that was almost without temperature. Even now, warm here would still bite your skin to the bone, but compared to the cloud around it, the center feels like a hearth. Pressure rises with temperature, and pressure does what pressure does best. It pushes back. Gravity and pressure find a balance that is never quite still. A live truce that slows the collapse to a pace of millions of years. That truce is what saves the forming star from vanishing into a point. It is also what gives the process time to be careful. There is spin in everything. The original cloud held a whisper of rotation, and as a region shrinks, that whisper becomes a clear, low hum. A figure skater draws in their arms and turns faster. The forming star gathers its gas, and the spin quickens. The result is a flattened disk around the growing center, a wide, thin halo where dust and gas circle in obedient arcs. Later, rocks will gather here. Ice will build layers. Planets will learn their lanes. For now, it is a soft ring, bright in infrared, cradling the glow of its central ember. The center has a name, protostar. Not yet a true star, not yet lit by fusion. Bright, anyway. Its light is the light of falling, turned to heat, of pressure finding its way outward. Deeper in, the gases squeeze so tightly that atoms surrender their electrons, and the material behaves more like a fluid of charged particles than a calm gas. Radiation tries to leave and gets scattered, absorbed, re-emitted again and again like a traveler finding many doors locked and trying each in turn. Some of that energy escapes along the easiest routes, the poles, where magnetic fields guide narrow, elegant jets. Beams of plasma lance outward for light years, thin and determined, clearing small windows in the cloud. Through those windows, the dark learns a new color. The collapse is not perfectly smooth. It pulses. Material rains inward from the disk in bursts, and each burst can feed the central glow the way a log feeds a small fire. The protostar brightens, then rests. It yawns out those polar jets again, carving little blue cavities into the brown of dust. Nearby gas, nudged by each pulse, may find itself dense enough to begin its own slow fall. One birthplace becomes many. A nursery becomes a neighborhood. Time here moves on a scale that shrinks human worry. In the stretch of 80 or 90 years that a person might live, the cloud changes so little you could make a before and after image and see only mood, not motion. Even across thousands of years, the difference is subtle, a suggestion more than a statement. Science stitches progress from many small looks, from patience across generations, from instruments that remember exactly what they saw decades apart. If you could watch the whole thing sped up, a glacier would seem rash by comparison. Yet slowness is not the same as uncertainty. Gravity keeps its appointment. Diversity enters early. As fragments collapse, their destinies diverge with their masses. Some will drink deeply from the cloud and become brilliant hot stars that blaze blue and spend their lives fast, like candles in a wind. Others will choose a modest burn and last for billions of years, with a gentle yellow steadiness like the Sunday. Many will stay small and bank their fires into red dwarfs, little embers that outlast almost everything else. A few will never quite make it, warming into brown dwarfs, no fusion in their hearts, but glow enough to tell their story in infrared. All of these fates begin in the same cold rooms, under the same dust, with the same lullaby of pressure and pull. There is a kind of kindness in the order of it. Light that will one day cross a galaxy begins hidden. A future that will cast shadows on a planet's afternoon starts in secrecy. Like seeds asleep under soil, stars first learn the silence in which to grow. Dust stands guard. Hydrogen waits without complaint. Gravity keeps the promise it always keeps. In that waiting, the universe practices becoming. From the outside, it is easy to think of a cloud as only a warehouse of raw material, a gray storehouse waiting for use. Step closer, and the feeling shifts. There is mystery here, and a stark beauty that doesn't need bright color to prove itself. The edges of a dark nebula against a river of starlight are as eloquent as any sunrise. The chemistry resting in the cold has a softness to it, the way simple molecules fold together, the way carbon begins to flirt with complexity. The promise held inside those veils is personal. New suns, new worlds. Maybe one day breath. Maybe one day a hand resting warm against another in a night not so different from this one. Deep in the densest part of a clump, the protostar's core keeps warming. Each small increase changes how the material behaves. The balance between gravity and pressure shifts by microns, then miles. The glow strengthens, not from nuclear fire yet, but from the continued conversion of falling into heat. The dust around it, heated from within, re-radiates that warmth in long waves our eyes cannot see. And so the place shines in wavelengths that feel like the body heat of the cosmos. Infrared observatories catch that quiet and turn it into color we can understand. Edges sharpen, jets continue. Sometimes those jets crash into nearby knots of gas and carve bright little crescents that bow away from the impact, like ripples frozen mid-ring. The whole region begins to look in the right light, like a workshop where someone cleaned carefully with a narrow brush. Cavities bloom, arcs bend, Filaments twist and merge. The protostar pulls, the disk feeds, the outflows prune. What began as shapeless cloud starts to carry the signature of an individual life. Even here, numbers can help without breaking the spell. The cloud that began near a few dozen degrees above absolute zero now shelters a center far warmer. The disk spans distances wider than the gap between our sun and the farthest planets that will one day form. The jets can travel for light years, narrow as pins and long as cities stacked end to end until they reach the moon. Yet it all remains so gentle in the telling that you could fall asleep to it without missing the meaning. Listen again to gravity's sentence. Every atom that falls inward deepens the well for the next. The rich get richer, but what they hoard is simply the ability to gather more. Pressure pushes back and saves the day, turning disaster into design. That is the secret engine of this stage, the live balance between a pull that would collapse all things and a push that would disperse them. Neither wins. The draw is the miracle, because it makes time for structure, time for disks to settle into planes, time for grains of dust to bump and cling and grow from motes to pebbles to stones. Time for the first maps of future orbits to sketch themselves in the quiet. Not every place inside a cloud ends with a star. Some clumps fail and return their material to the common pool. Some move too near a neighboring giant whose light shreds their potential. Some are trimmed by the very jets that announce their siblings' progress. Even that is part of the kindness, because nothing is truly wasted. What drifts away becomes food for the next beginning. The cloud as a whole is a patient recycler, and the galaxy above it is a larger one still. It helps to remember where the dust came from. Long before this night, other stars burned and ended. Some died softly, letting go of their outer layers like a breath. Some ended with ferocity, scattering the sky with new elements. Out of that end came the grains now sheltering this beginning. The universe likes loops. The iron in your blood once rode a shockwave. The calcium in your bones once cooled from a hot wind. The oxygen in your next inhale once spun as part of a star's bright labor. All of it passes through the nursery again, waits in the dim, and learns the steps of the old dance one more time. The sound of it, if sound could travel here, would be thin as silk, a hush with texture, turbulence speaking in a language of eddies, collisions too gentle for thunder, motion so protracted that it feels like stillness. That is the right pace for tonight. To hold the life of a star in mind, you move slowly enough for the details to come find you. The details are not numbers we must recite, not footnotes to memorize. They are the feel of cold, and the permission of dust, the patience of gravity, and the first modest glow in a place that refuses to hurry. Somewhere in the cloud, one clump has grown heavy and warm enough that the next threshold comes into view. The core is edging toward a new kind of light, self-fed, balanced, long-lived. Not yet. There is still gathering, still shaping. Jets flicker like quiet lightning, and the disk lets matter fall as a soft rain. But the direction is clear. The ember is nearly a hearth. Think of a seed. For a long time it's only promise. Then a point of green appears and inevitability follows. The protostar is at that point. The disk turns slow, sure. Farther out, other clumps test their beginnings. A few will become companions. Many will fade. Across millions of years, the region works like a single loom. Threads of gravity and dust and old starlight pulling a shared pattern. From where you're resting, shoulders loose, breath easy, it all belongs to the same quiet sentence. First heat, patient cloud, dust shade, narrow jets, calm spin. Nothing is rushed. Nothing is wasted. In the deepest pocket of dark, the first heartbeat keeps time, and the light that will one day cross a galaxy is practicing how to begin. Jets look fierce in images, but they're simply balance made visible. As the newborn gathers mass, it gathers spin. The polar beams are the release, the first cries into the dark. They run straight for years upon years, clearing lanes through the veil that hid everything. The scene looks fast. The truth moves at a glacial pace. From the first subtle sag of a dense knot to a steady protostar, millions of years drift by. To the cosmos, a blink. To us, an era. And still the same homely physics applies. The warmth in a bicycle tire after you pump it, the heat in your palms when you rub them, compression and friction belong to the same family that warms a collapsing heart of gas. Only the scale has changed. Not a handful of molecules, but uncountable numbers. Not seconds, but epochs. As the protostar grows, it begins to push back. Light leaks from the center as heat, and that heat lifts the pressure in the surrounding gas, slowing the inward rain of matter. A balance forms that is more truce than peace. Gravity pulls down, pressure pushes out, and the young object holds its shape within that tension. It is not yet a true star, no steady nuclear fire in the core, but it is no longer only cloud. It has a boundary, a pulse, a future. The feeling of this stage is anticipation, a match paused against its box. The tinder is ready, the hand is steady, the strike has not quite happened. Whether the strike will take depends on weight. If there is enough mass, the core temperature will climb toward a threshold where something new can happen. If there isn't, the glow remains an ember that never quite brightens. A brown dwarf, warm, dim, honest about its limits. Gravity sculpts either way. It pulls raw gas into a tight seed. It squeezes until the stored energy of falling becomes heat, until the inside is far warmer than the night around it. The protostar hangs there between potential and reality, proof that the quietest forces, given time, can rearrange a universe. The glow that rises inside is at first a secret. Dust holds the visible light captive, but lets longer, softer wavelengths slip out. Telescopes tuned to infrared can see what our eyes cannot. A small sun to be wrapped in a wide, flattened disk, the natural shape that spin makes when a cloud falls in on itself. Within that disk, grains the size of smoke drift, touch, and cling. Two motes become three. Three become a clump. Clumps learn to keep company. These are the earliest sketches of planets and moons, written in powder and patience, while the central fire finds its breath. The disk is not quiet in the way a lake is quiet. Friction warms its inner lanes. Shocks run along its spirals like ripples that never die. Radiation from the center stirs, eddies, and wakes. Close to the protostar, the material heats and glows in infrared. Farther out, it stays cold and dark, a shadowed ring waiting its turn. Spirals sometimes appear, sculpted by turbulence or by lumps heavy enough to pull their neighbors into line. Chaos has a pattern here, and the pattern looks like art. Above and below, the show sharpens. Jets of plasma launch from the poles and cut through the cocoon at speeds of hundreds of kilometers each second. They are narrow, disciplined, and astonishingly long, stretching across light years. Where they slam into the surrounding gas, they paint bright knots that observers give a gentle human name. Her big harrow objects little lanterns marking the path of a star's first breath. To the eye, they are brushstrokes on velvet. To physics, they are relief valves, shedding excess spin so the center can settle. Collapse makes outflow. Outflow makes room. Room lets the center gather itself. The scene reads as violent, but the rhythm is the rhythm of a slow dance. Deep inside, the numbers change their register. What was thousands of degrees becomes tens of thousands, then more. Each atom that falls adds pressure. Each collision inside the core lands with greater force. Near 10 million degrees, the most important whisper in creation begins. Hydrogen starts to fuse into helium. At first, it is a trickle. Only a few protons find themselves close enough, fast enough, to push through their mutual refusal. Even that trickle releases energy. The energy moves outward, joining the glow made by collapse, feeding the balance from the other side. It feels like watching a fire. Take the first ember, the first lick of flame, the moment when the wood stops being separate pieces and starts being a single warmth. This is the hinge on which so much turns, a shift from heat made by falling to light made by fusion. Gravity keeps pulling. Nuclear forces begin to push back with their own steady insistence. The young star wobbles while the two learn each other's strength, swelling and settling in slow oscillations that can last thousands of years. That flicker is not failure. It is the last small tuning before a long steadiness. Even wrapped in dust, the new light finds paths. Infrared and radio glide out and tell their stories to instruments aimed at places like the Orion Nebula. There, hundreds of protostars shine as embers, each circled by a disk, each announcing the same truth. Our own system once rested in such a cradle about 4.5 billion years ago, hidden from ordinary sight and yet busy with beginnings. A single object like this can spend millions of years moving toward full ignition. In that time, seeds of worlds take hold in the disk. Some will harden to rock, some will store ice, a few might one day wear air and water. All of it waits on a simple fact in the core: hydrogen fusing to helium, the small loss of mass turning into a great flood of energy. Mass sets the temperament. A heavy protostar blazes blue and fierce and uses its fuel quickly. A small one glows red and careful and can outlast empires of time. Color is character. The jet's rhythm is personality. The disk's shape is a first sketch of what the family of worlds might be. Each case is its own story, all with the same alphabet: collapse, gravity, fusion, light. There is a soft paradox at the heart of the scene. Jets roar, disks churn. The core crushes matter into densities beyond any daily experience. Yet from far away, it all unfolds as a kind of silence. The grace is not the absence of chaos. It is the harmony that rises from it. Dawn is a better metaphor than spark. Fusion does not arrive like a match head flaring. It spreads like morning, faint, then sure, then unstoppable. With that, the protostar crosses a threshold. It breathes as a star for the first time, ready to last. Equilibrium finally settles in. Gravity holds with its inward pull. Fusion answers with outflowing pressure. The two match. The star has come to its long middle. Astronomers give that span a name main sequence, but the feeling of it is simpler. The calm at the heart of a very big engine. This calm can endure for billions of years. In that stretch, continents wander, species come and go, and entire languages are born and forgotten on any planets lucky enough to circle near enough. And still, the parent light barely wavers. The heart of the calm is one repeating act. 4 protons, through a chain of steps, become a helium nucleus A tiny fraction of their mass vanishes and reappears as energy, as told by the compact simplicity of E equals mc squared. The lost mass is minute. The square of light speed is enormous. The product is sunlight. Photons born in the core do not fly straight to freedom. The interior is so dense that each packet of light is absorbed, scattered, re-emitted, and sent wandering again and again. A single photon can spend hundreds of thousands of years in that random walk before it reaches the surface and finally escapes as the warm, visible glow that touches a leaf or a cheek. Step into a sunbeam, and you are catching the last moment of a journey older than every story your species remembers. From a distance, the star looks serene. Inside, it is alive with motion. In some, great cells of gas rise and sink in slow convection, lifting heat like the world's largest pot, coming gently to a simmer. In heavier stars, radiation does more of the carrying, with photons threading their way outward through layers of gas. The details shift with mass and temperature, but the promise is constant, a steady outflow of energy, predictable enough for oceans to stay liquid and for atmospheres to keep their balance. Amid supernovas and black holes and galaxies tangling, this steadiness is a small miracle. It is the quiet heart of cosmic time. Not every star lives the same length of quiet. Lifespan is written almost entirely in mass. The large live fast and end early blue, brilliant, and gone in a few million years. The small live with thrift and patience, red dwarfs sipping their hydrogen so slowly they can shine for trillions of years, longer than the universe has yet existed. Our sun is comfortably in the middle, on track for a main sequence life of about 10 billion years, roughly half of which has already passed. We orbit a lantern built for the long haul. Nothing about this calm is dull. A star's surface still seethes with small weather spots, flares, waves that ring its body like a bell, but the average holds. Day after day, year after year, its output stays steady enough for a world to try its experiments. Oceans learn tides, rocks learn rivers, cells learn memory. In that long middle, the universe keeps its promises slowly, and the deep story stays simple enough to whisper, balance atop balance. Collapse became heat, heat became light, light became a constant hum. Photons take the long, crowded route outward. Jets shed spin so the center can stand still. The disk turns and sows seeds that might one day wear clouds. In the midst of it all, the star stands as a keeper of time. What began as a cold knot in a silent cloud now shines, not urgently, not loudly, but with the steadiness a sleeping mind understands. That light carries something else, too, its own tint, a quiet clue to how hot it truly is. Color is temperature you can see. The hottest, heaviest stars pour out a blue-white glare, clean, fierce. Cooler ones lean orange or red, their light softer, their lives slower. Between them are stars like our sun, yellow, white, and steady, a lantern with a patient flame. These hues aren't just pretty. Their quiet signatures hints about mass, heat, and age, little truths you can read at a glance. A sky full of stars is a sky full of clues, a rainbow of long lives, unfolding at once. Even in this long calm, nothing is truly still. Deep in the heart, hydrogen steadily becomes helium. Helium is heavier, and so it gathers at the very center like a slow snowfall. The balance shifts by degrees you can't see. Pressure and temperature retune themselves. The light edges upward. Across human time, the change is invisible. Across geologic time, it shapes worlds. Our own sun shines about 30% brighter now than when life first stirred in Earth's waters. No creature felt the click from one generation to the next, yet oceans and climates quietly adjusted to a lantern that, very gently, turned its wick. In this phase, a star plays host and architect. Its light sculpts nearby clouds, carving shapes where dust and gas retreat. Its winds thin streams of charged particles that flow outward comb through the local space, trace magnetic lines, and sweep delicately across the skins of planets. Its gravity gathers and keeps, teaching smaller bodies their paths, coaxing order from the leftover haze of a birth long past. Elements that older stars forged are carried forward into new stories, so that the atoms in your breath have already lived other lives, heated, cooled, blown free, folded into rock, lifted into a leaf, and finally invited into you. Stardust is not a metaphor, it's a lineage. The patience of a main sequence star stretches the mind. 1,000 years to a star is a single, gentle tick. To call one middle-aged may mean it has already been shining for 5 billion years and intends to continue for about 5 billion more. Time takes on a different texture here, elastic, spacious, kind. And yet the gift isn't abstract. It spills through a window each morning, warms skin, drives weather, makes sugars out of sunlight inside green leaves, and keeps seas from freezing into glass. Calm can be a powerful thing. If this long span has a theme, it's endurance. The universe inhales and exhales through these suns. They are the heartbeat that makes everything else possible. Warmth for oceans, light for eyes, steady days for slow experiments called ecosystems. The star is not rushing toward an end, not trapped in a beginning. It simply is radiating, balancing, giving what it can for as long as it can. In the story of the cosmos, this is the chapter with the most pages. Stars linger here, quietly weaving hydrogen into helium, throwing light into the dark, holding open a window long enough for wonder to arise. Deep inside, the journey of light begins with a single event. In the crush and heat of the core, 4 simple protons, through patient steps, become one helium nucleus. A tiny slice of mass slips away and returns as energy E equals mc squared, plain and profound. Each act of fusion releases a photon, a little packet of light. You might imagine it arrowing outward, but the inside of a star is no place for clean exits. It is a crowded, jostling ocean of plasma, where nuclei and electrons press shoulder to shoulder. The newborn photon runs into a neighbor almost immediately, is absorbed, re-emitted, nudged sideways, nudged back. It zigzags like a lost traveler in fog. This is a random walk with no straight lines. The progress is slow beyond patience. If the interior were empty, a photon could cross in seconds. Instead, the trip can take hundreds of thousands of years. Some wander for more than 1 million. Think of light not as a streak, but as a pilgrim, pausing at every door, passing its message from hand to hand through an ancient crowd. Meanwhile, the star's glow never seems to falter. Trillions upon trillions of photons are on the move at once. Their individual stumbles add up to a steady outflow, the apparent constancy that lets a planet keep its weather and a forest keep its green. On the journey outward, the light changes character. A fierce gamma ray born in the core loses energy by countless scatterings and re-emerges nearer the surface as a gentler photon. The beam that finally slips free as visible light is the many times removed descendant of the original burst. Sunlight is recycled starlight, handed along so many times that its brightness becomes hospitable, warmth you can feel on your face. At the photosphere, the visible surface, the labyrinth ends. The photon is released into openness. In the vacuum of space, nothing leans in to interrupt. In less than 8 minutes, a ray from the sun crosses the 93 million miles to Earth. After ages spent inching through the star's body, the final dash is almost comedic in its speed, like a traveler trapped in traffic for 500,000 years who finds the last mile home empty and bright. Beyond the star, light becomes a messenger. Blue tells of heat, red of cooler layers. Tiny dark lines, absences, really etched across a spectrum reveal which elements live in the star's skin. Astronomers read these lines the way you might read a familiar handwriting, recognizing the shapes of hydrogen, helium, sodium, calcium. A glance becomes a conversation with a distant furnace. The distances are their own kind of music. Sunlight is 8 minutes old when it reaches us. Light from the nearest star beyond our system travels a little more than 4 years to arrive. The glow from the Orion Nebula began its journey over 1,000 years ago, before the first castles lifted their stones in Europe. The soft light of the Andromeda Galaxy is more than 2 million years old, older than the tools shaped by early humans who had just begun to teach stone to fit the hand. Every night sky is a museum of old departures seen all at once. Some photons travel much farther. The faint light from remote galaxies has been on the road for billions of years, carrying news from when the universe itself was young. They crossed while galaxies were only learning their forms, while the cosmos glowed more evenly, while Earth and Sun did not yet exist. Photons don't tire. They don't age in the human sense. They speed along until they meet something that can take their energy, a leaf, a grain of dust, the mirror of a telescope. Many spend eons in lonely space, stretched to redder wavelengths by the slow expansion of everything, patient to the end. That the beam touching your floor this morning may have started as a gamma-ray heartbeat deep in the sun's core, long before the first cities rose, is a thought with a gentle weight. Every sunbeam is a long letter delivered at last, a note written in the alphabet of wavelengths. The stars are storytellers. Photons are their syllables. When you look up, you're not just looking out, you're looking back, reading a page that left its author long ago. A star is more than a point of light. It's an engine of creation and a foundry for elements. Without stars, the universe would be an enormous, thin hush of hydrogen and helium. With stars, the hush gains texture and color, chemistry and weather. Fusion begins simply hydrogen to helium and climbs when the conditions allow. As stars age and their cores change, heavier elements appear. Helium can become carbon. Carbon can become oxygen. Oxygen can feed neon and magnesium, and onward towards silicon and iron. This is stellar alchemy, the slow filling in of the periodic table. Even so, iron is a kind of wall. Fusing it doesn't pay back energy, it demands it. To go past iron, the universe waits for endings that act like beginnings. When a massive star dies in a supernova, the shock heats matter to ferocious temperatures and squeezes it under extravagant pressures. For brief moments, nature has the tools to forge the heaviest elements: gold, platinum, uranium. They are thrown outward in the debris. Later, they drift into clouds, then into disks, then into worlds, and finally into fingers, rings, and bones. The gold in a band, the calcium in a smile, both remember a star's last act. Stars don't only change chemistry. They change shape on the grandest scales. Galaxies are held together in part by the combined pull of their stars. Without them, a galaxy would be little more than thin gas spread in a shy haze. With them, spirals curve, bars form, clusters gather, and irregular smears take on personality. Inside those shapes, massive young stars carve cavities with ultraviolet light and strong winds. They compress nearby gas and sometimes nudge it across the line into collapse, starting new rounds of birth. One generation invites the next. A nursery begets a neighborhood. A neighborhood becomes a lineage. Our sun is ordinary by galactic standards, and yet its influence here is absolute. Its gravity threads our system together. Its light runs the weather. Its warmth powers photosynthesis and feeds the long chain of life. Without its steady mood, Earth would be a frozen rock wandering the dark. A star is not a distant abstraction. It is the center that gives a world both clock and hearth. On scales too large to hold in mind, stars have done even more. After the Big Bang, the universe was simple and dim, filled mostly with hydrogen and helium, fogged by its own cool gas. When the first stars kindled in that dusk, their ultraviolet light reionized the surrounding medium, cleared the fog so that light could run more freely. Their deaths planted heavier elements into the blankness. Their gravity herded matter into the knots that would become early galaxies. The sky became detailed because stars arrived to draw the details. Delicacy runs through this. A balance, easy to overlook. Too few stars, and the universe would never gather the ingredients for complex chemistry, much less biology. Too many, and the violence of their births and deaths would strip away the calm needed for planets to hold air and water. For all its scale, the cosmos learned a kind of moderation, letting stars be numerous enough to enrich, spaced enough to allow quiet to take hold. Not all stars share the same pace. Mass writes the calendar. The giants live fast and end early blue, quick, brilliant, measured in millions of years. The smallest sip their fuel and glow red for trillions of years, stretches longer than the universe has yet existed. The sun sits between, a main sequence life of about 10 billion years, now somewhere near the comfortable middle. It's a good compromise for a world that needs steadiness more than spectacle. Inside, the slow migration of photons never stops a patient tide drifting from unbearable heat toward the cool of open space. In some stars, convection cells rise and sink like a quiet simmer. In others, radiation alone carries the load, a steady leak of light through dense, glowing layers. Weather flickers across the surface spots, flares, rippling waves that circle the sphere, like the echo of a struck bell, but on average, the balance holds. Constancy is the gift. Because a star does not lurch from bright to dark, oceans stay liquid, air stays kind, and life has time enough to learn itself. This is generosity on a cosmic scale. Giving without haste, giving without pause. The main sequence is the universe keeping a promise, not to a single world, but to the possibility of worlds. It is the long inhale during which galaxies shine and planets find rhythm. It is where atoms rearrange into the tools of future stories, where thought can finally look up and recognize the path that light took to reach it. So when a star twinkles its beam, nudged by the trembling air above, you can trace it backward in your mind, born in fire, trapped for ages in a crowd, freed at last into a sprint. It crossed distance and time to touch your eyes, the gentlest arrival of something unimaginably old. Even the faintest glimmer carries history and endurance, a quiet invitation to belong to something larger than a night, a room, or a single, steady breath. But this balance is fragile. Too many heavy, short-lived suns in one place, and their violent deaths would tear young galaxies apart before gentler things could take root. The cosmos seems tuned to a slower rhythm, a give and take where creation and destruction share the same breath. That rhythm lives here too, written into what surrounds you. Iron rails that sing under passing trains, silicon whispering inside a chip, oxygen easing in and out of your chest. Each of these once moved through the heart of a star, warmed, scattered, and gathered again into shapes that remember heat without being consumed by it. To walk the earth is to tread on sifted stardust. To look up is to read your own beginning, written long ago in distant light. There's no intention in any of this, no plan, no goal. Stars don't know they are carving galaxies or laying down the elements for breath and bone. Gravity draws inward. Fusion pushes outward. Matter rearranges under pressure and heat. From rules so plain a child could name them: pull, push. Warm comes gold in a ring, a shell on a beach, a mind wondering about both. Quiet humor lives there, that the things we prize for their beauty, platinum's sheen, the friendly glow of a fireplace ember, are side effects of stars going about their ordinary work. Generous artists, unself-conscious, painting the room and never turning around to admire the walls. To see what stars are doing is to feel the sky not as backdrop, but as performance. Each point of light is both musician and instrument. Gravity keeps the beat. Light carries the melody. Endings arrive like cymbals, and, in their ringing, new themes begin. Stand under that music and let your eyes relax. Every twinkle is a forge. Every soft glow is a beacon. Every faint shimmer is a reminder that the universe prefers change to stillness. The atoms that shape your hands share kinship with those far lights born in fire, ferried by time, assembled into you with a patience that feels like kindness. What seems at first a scatter of white dots is, with a longer look, a page of colors and sizes. Some stars breathe red, some shout white blue, some wear gold and pale amber. The differences are not decoration, they are identity. Astronomers sort these lives with a simple portrait called the Hertzsprung-Russell diagram, the HR diagram for short. One axis is brightness, how much light a star sends out. The other is temperature, how hot its surface is, which shows up as color. Plot them, and patterns appear. The largest family stretches in a broad diagonal, the main sequence where stars spend most of their long middle lives, turning hydrogen to helium. Where you land on that band is written mostly by mass. Heavy stars blaze blue and fast. Small ones glow red and take their time. Mass, here, is a kind of destiny. At the dim end of that band are the red dwarfs, so common they likely make up nearly 3/4 of all stars. Small, cool, modest to the eye, often invisible, without help. Their thrift buys them ages beyond imagining. They sip hydrogen so slowly they can shine for trillions of years, longer than the universe has lived so far. Somewhere, red dwarfs, born not long after the first dawn of stars, still glow on, custodians of time. At the other end sit blue giants large, bright, blisteringly hot, throwing off light tens of thousands of times the sun's. They are magnificent and brief. Fuel goes fast. Lifetimes measure in a few million years. Exits are loud. Fireworks against a dark river. Between those extremes are many lives. Orange dwarfs, a little smaller and cooler than the sun, settled and long-lived. Yellow stars like ours, steady day-givers that hold warm zones where oceans can stay liquid and weather can learn its patterns. Subgiants, just beginning to drift from the main sequence, as the hydrogen at the core grows thin. Giants, swelling and softening in color, as helium burning begins and outer layers balloon. On the HR diagram, each of these has a place, and each follows a path as it ages, a biography written in brightness and hue. Color itself is a gentle physics lesson. Hotter stars pour more energy at shorter wavelengths, so they look white or blue, like a metal heated to a fierce glow. Cooler stars lean to longer wavelengths, and their light reddens, like the eye of a stove just warming. A red star is the sky's ember. A blue star is the universe's blowtorch. Our sun rests in the middle. A G-type main sequence star, modest in heat and light, yellow-white to our eyes, steady enough to keep a planet temperate for billions of years. Larger and hotter, it would burn through its time too quickly for forests to learn leaf and for minds to learn questions. Smaller and cooler, its habitable band would tighten, and worlds might struggle to stay warm. The sun is, in the old story's phrasing, just right. As stars age, their dots slide across the HR diagram. With hydrogen dwindling at the core, the balance shifts. Some swell into red giants, their outer layers drifting outward until they are hundreds of times wider than they began. Others finish small, as white dwarfs, Earth-sized embers with the mass of a star's heart, shining faintly as they cool down through eras. There is order in this, not chaos. A sky that looks random becomes, on the diagram, the clean geometry of a life cycle. Variety in stars becomes variety in worlds. Red dwarfs often host planets tucked tight to their warmth. Some of those worlds likely turn one face forever to their star, one hemisphere in endless day, the other in constant night, with a twilight ring between where winds tug at the line. Blue giants, too brief to nurture life as we know it, still matter. Their winds and their bright deaths push on nearby clouds and can spark fresh rounds of star birth. Yellow stars like the sun offer slow stability, a platform on which ecosystems can try their long experiments. In spiral galaxies, glowing blue clusters light the arms where new stars are born. In the old, round bulges at the center, redder, older stars keep their quiet. Color maps history. It's easy, lost in the softness of starlight, to forget the weights involved. Yet the sun alone dominates our small neighborhood. About 100 Earths could line up across its face, and its mass is more than 300,000 Earths, enough gravity to thread planets, moons, and comets on stable paths for eons. Ordinary by galactic standards, extraordinary to us. Not the biggest or brightest, just the one that keeps our water liquid, our air moving, our days in step, a hearth more than a spotlight. And still the balance holds on larger scales. Too few stars, and the universe would be thin of elements, no carbon for branches, no oxygen for waves, no phosphorus for memory. Too many big ones in too tight a crowd, and their fury would scrub the calm from young galaxies, heating and tearing before gentler work could begin. The cosmos found a middle course without thinking about it, because gravity and gas and time, following their rules, make moderation the natural outcome more often than not. Enough fireworks to stir the ashes. Enough embers to keep the room warm. The night sky is a slow rainbow, one hue per lifetime. Red dwarfs that will outlast every name we invent. Blue giants that flare, dazzle, and disappear. Swollen orange giants breathing gently, white dwarfs cooling like forgotten coals, and our sun steady, yellow, white, giving us time. Each color is a fingerprint of mass, heat, and age, and each one is a quiet forecast of what's to come. A redder glow means patience. A bluer blaze means urgency. A steady gold means seasons, stories, and the long chance to grow. When you notice a star's subtle shift in color, slightly amber here, faintly icy there, you're seeing more than shade. You're catching time itself, clocks running at different speeds. Each point of light is a biography, written in the same alphabet but at its own rhythm. And when you look down again, at the book in your hands, or the cup cooling beside you, you're still inside that same story. The iron in the glaze, the silicon in the chips, the oxygen between leaf and lung, all of it born in stars, scattered, gathered, and born again. The stars shaped the universe, and in a very literal way, they shaped you. Tomorrow, the sun will rise, as it always has, billions of mornings, and counting ordinary yet absolute. It will draw the tides, color the leaves, move the air, and warm the stone. It will keep its quiet promise at the core, turning hydrogen into helium, giving light, holding balance, no fanfare, no pause, just the calm authority of something that understands endurance. And beneath that light, life keeps learning how to notice, how to listen, how to tell the difference between the quick blaze and the long glow. The sky remains both precise and tender, a canvas where every color is a sentence about time, energy, and the chance to wonder. The warmth that touches your skin feels gentle, but its source is relentless. Deep within the sun, where pressure erases distance, simple hydrogen nuclei press close enough to fuse into helium, and every union releases energy. Each second, nearly 4 million tons of the sun's mass become light. That number defies imagination. Yet from 93 million miles away, the delivery is soft. Enough for oceans to stay liquid, clouds to wander, forests to green, hands to stay warm. Earth's orbit happens to sit in a rare, temperate lane, the habitable zone, where water can remain water. Call it luck, call it balance. Either way, it is the quiet gift we live inside. Balance, not drama, is the sun's habit. It doesn't strobe or sulk. It doesn't cut the power without warning. It hums. When life first stirred in seawater nearly 4 billion years ago, that hum was there. When dinosaurs leaned their heavy heads into wind, the same star watched them. When early humans tilted their faces up and tried to name what they felt, it was this steady light warming their bones. Continuity like that is rare. It steadies the pulse. Yet steadfast isn't the same as unchanging. The sun evolves, only so slowly that no single lifetime could notice. As hydrogen fuses, helium gathers in the core, the ash of stellar fire. Helium is denser. It changes the internal balance of pressure and temperature, and the sun brightens by small degrees over long spans. In youth, it was about 30% dimmer than it is today, which leaves a soft riddle behind called the faint young sun paradox. How did early Earth keep its water from freezing? The answer likely lives in thicker blankets of greenhouse gases and other planetary tricks. But the puzzle keeps a quiet place in the minds of people who study ancient climates and old light. Ahead, there is time. The sun is roughly halfway through its long middle, with about 5 billion years of easy burning left. For now, the furnace purrs, reliable as a tide. But the script bends in the distance. As fuel thins at the center, The core will contract and heat even more. The outer layers will loosen and swell. The star will redden and grow into a giant. In that far future, the inner planets may be swallowed or scorched beyond the idea of sea and sky. Oceans will lift into vapor. Air will shine. It will look like a different star wearing the same name. Even then, the ending will be quiet compared to the fireworks of massive suns. Ours is not heavy enough to explode as a supernova. It will let go more gently, shedding its outer layers in lovely, thin shells, a planetary nebula, so the surrounding space briefly wears a luminous veil. What's left will draw tight into a white dwarf, Earth-sized, star-heavy, shining with stored heat. That ember will fade over billions more years, cooling into a black dwarf, a dark memory in a dark age, graceful, not violent. And even that grace continues the old generosity. The carbon, oxygen, and nitrogen breathed into the galaxy during that shedding will drift outward and someday fold into new clouds, new disks, new worlds. The story moves in circles that look like lines from close up. What makes the sun special isn't spectacle, it's composure. In a galaxy with wild, short-lived blue flares, our star chose a longer path. A main sequence life of about 10 billion years is roomy enough for chemistry to learn complexity, for cells to experiment, for forests to sketch the air, for minds to wake and ask questions. Without that patience, Earth's story might have been a spark and a sigh. People felt that long before there were equations. They aligned stone to its rising and setting, listened for the hinge of the year at solstice, marked equinox light in corridors of rock. They painted and told stories, chariots, golden eyes, sky travelers. Science later taught us about plasma and fusion, but the old instincts never left. We still speak of dawn as a start, sunlight as joy, sunset as release. The sun arranges not only physics but rhythm, work and rest, sowing and harvest, the tilt of seasons across skin and soil. It is ordinary the way a heartbeat is ordinary, constant enough to be ignored, essential enough to carry everything else. Touch a sunlit windowsill and you're feeling time distilled. A photon born in the core wandered through dense plasma, bumping and waiting and being passed along for hundreds of thousands of years. Freed at the surface, it sprinted through space in less than 8 minutes and landed, light as a feather, on your hand. Warmth as a message, with a very long preface and a short, closing line. To think about the sun is to think about scale and balance at once. Large enough to gather planets and keep them. Not so large that it burns out early. Bright enough to power life. Not so intense that it peels atmospheres away. Steady for billions of years. Steady for billions more. It is, by catalogue, an ordinary G-type star. By circumstance, the axis of our days. Its quiet makes room for everything loud that life wants to try. Still, even the most patient stories turn a page. Inside every star lives a contest. Gravity pulling in, energy pushing out. For ages, hydrogen fusion keeps the match even. But hydrogen is not an infinite well. As the core fills with helium, there is less fresh fuel at the very center. The core contracts, heat rises. Paradoxically, although the central engine is changing, the outer layers swell and the overall brightness creeps upward. From Earth, the difference arrives too slowly to notice. No sunrise announces, "I am 1/10,000th brighter," but across geologic diaries, the entry is clear, stronger light. A few billion years from now, Before the sun wears its red giant robes, that extra brightness alone could be enough to evaporate oceans and rearrange climates beyond habitability. The pace is slow, the stakes are large. Inside, structure grows layered. With the core compressed and hot, a shell around it becomes the new workshop where hydrogen keeps fusing. Later, for heavier stars, helium lights in the core, and still more shells form an onion of fire, each layer making different elements, each destined eventually to drift and seed new places. The physics stays simple in spirit, even as detail grows. When push from fusion weakens, pull from gravity squeezes. The squeeze heats. Heat lights fresh fuel where it can. The star responds by changing size and color. For the smallest, reddest stars, this whole arc stretches beyond the universe's current age. They sip their fuel so slowly that none has yet reached elderhood. We have never seen a red dwarf die. For stars like the sun, the signs are subtle but known. The long quiet of the main sequence gives way to a more restless grace, brighter, larger, redder, before the gentle shedding and the compact amber. From here, under this ordinary sky, the changes are almost too slow to call changes at all. No single year tells the tale, yet the tale is certain. A few percent more light can alter currents, shift forests, move the lines between snow and rain. Stars carry both stability and transformation in the same hands. Their patience is not passivity. It is the speed at which big things choose to move. At the end of the sun's middle, the helium core will be a weight the star cannot ignore. Gravity will pack it into states that make earthly matter seem loose as fog. Under those conditions, the next chapters open. For heavier stars, new fusions begin. For ours, the swell and the letting go draw near. It is easy to speak of stars as if they were people, birth, life, age, death, because the arc is familiar. But their aging wears a different clock face, eons for steps, eras for breaths. The direction, though, is the same one any living thing recognizes, a slow turning toward change. Hold that thought lightly. The sun is not rushing. It is balanced tonight and tomorrow, and long after any calendar you could carry in your mind. It will rise and shoulder the weather, pull the tides, feed the green. It will keep converting mass to light at that astonishing rate, sending photons on long, patient journeys that end as a warm touch on a cheek. In that quiet reliability is a kind of affection unspoken, unintentional, and absolutely real. There's a soft beauty in how certain this is. The same forces that once kept a star steady now redirect it toward generosity. Inside those aging hearts, elements are being prepared, carbon and oxygen first, and later heavier seeds that will one day drift outward and lace new clouds. Each subtle brightening, each quiet squeeze of the core is a step towards scattering what future oceans and leaves and bones will need. The star's aging isn't only an ending, it's the opening line of uncounted beginnings. Look up, and you catch them mid-step. Some are still in their calm youth, yellow, white, and patient. Others have begun to lean redward, their light tinted by changes within. They remind us that even the most reliable lanterns belong to time. Stability itself is a phase, not a promise forever. There's a hint of sadness in that, an awareness that the steady light we depend on will change its face. But there's also grandeur, because this slow change is how the universe keeps replenishing itself. Aging stars are the crucibles of creation. Their shifts remake the raw material of worlds. Where we might expect silence, they leave a legacy. The tempo is unhurried yet sure. The core tightens. Fusion moves. Brightness grows. Shells appear. Layer by layer, quietly and inevitably, a star walks its path. When the reserve of central hydrogen thins past a threshold, patience gives way to change. Gravity squeezes the helium-rich center until the heat climbs and the whole structure answers. What was a modest globe begins to swell. A red giant is coming into its own. Swelling sounds gentle, and it looks gentle from far away, but the scale is astonishing. Picture a sphere expanding until its diameter is hundreds of times what it was. Our sun will one day grow so vast that Mercury and Venus will be folded inside its atmosphere. Earth may follow, or else survive, as a scorched relic under a sky of red. Even survival would bring no comfort. Oceans would be steam, rocks would glow, air would shimmer with heat. From a distance, though, the change has a strange grace. The stars' outer layers puff like a great lantern, their color shifting to red-orange as the surface cools. Gentle roar fits. The surface seems mild, but the center is thundering. The core's contraction drives the temperature high enough for helium to begin fusing. 3 helium nuclei join to make carbon in the triple alpha reaction, and with an extra step, oxygen appears. That new energy swells the star, inflating it into a luminous globe that looks softer even as it grows more powerful. Cooler skin, greater reach the light total climbs by orders of magnitude. Dim to the touch, brilliant in some. Stand, if you could, on a surviving world around such a star, and the sky would be a single presence. The swollen sun would crowd the horizon, tinting everything crimson. Shadows would go long and pale. Nights would fade into a permanent dusk. Heat would press from every direction. Beautiful, yes, a cathedral of red light, and absolutely lethal. That's the paradox of the red giant. Catastrophe nearby, generosity to the galaxy. The same expansion that cooks planets also loosens the star's grip on its outermost layers. Winds rise and carry gas and dust into space. The thin atmosphere billows outward in shells and veils, each breath enriching the dark. What looks like loss from one vantage is gift from another. Inside, the architecture grows intricate. Fusion no longer keeps to the center. A shell of hydrogen burning wraps the hot helium core. Deeper in, freshly lit helium burning keeps the core alive. In heavier stars, more layers ignite and turn carbon, then oxygen, and onward. The star becomes a living onion, nested shells, each with its own fire. It's an elegant design drawn by necessity. Gravity pushes in, energy pushes out. When one source weakens, the structure reshapes to find another. The red giant phase can last surprisingly long. For a sun-like star, on the order of 1 billion years' time, enough to sculpt the local space with wind, to lay down wide clouds, to send a signature into the surrounding night. Some red giants are close enough and bright enough to be old companions to the eye. Betelgeuse, the red shoulder of Orion, would reach beyond Mars if it sat where our sun is. Antares, the heart of Scorpius, glows like an ember in a vast hearth. They are reminders without menace. This is the common road for stars of a certain weight. Our sun is not special in this. The physics is written into its center already, waiting for its hour. The idea carries a quiet weight for us. One day, Earth will not be Earth as we know it. Seas will vanish, continents will shine, and even the hardiest microbes will find nowhere to hide. The thought lands with gravity, and then, if you let it, with a kind of comfort. Impermanence is not failure. What ends here begins elsewhere. The carbon and oxygen made in a gentle roar will drift and cool and join new clouds. New disks will rise around new suns. New worlds will take shape. The atoms that hold you together may one day belong to another shore. The universe doesn't stop. It hands the torch forward. Deeper in, the story tightens. For billions of years, hydrogen fusion was the heartbeat, simple fuel, simple product, balance maintained. As that supply runs thin at the center, the star is forced to find a new rhythm. The contracting core reaches temperatures where helium can fuse. For stars like the Sun, this ignition can be sudden because the core has become degenerate, matter packed so tightly that pressure no longer depends much on temperature. The result is a helium flash, not an explosion to shred a star, but a rapid onset of fusion that releases an enormous pulse of energy. That pulse rearranges the interior, relieves the degeneracy, and lets the star settle into a new balance, with helium burning at its heart. Helium, like hydrogen before it, is a chapter, not a book. When much of it is spent, the core contracts again, growing hotter still. Around it, a hydrogen-burning shell and a helium-burning shell can work at once, two rings of fire feeding the star's glow. In more massive stars, the ladder climbs higher. Carbon fuses into neon, magnesium, and sodium. With further heat, oxygen burns into silicon and sulfur. Silicon, at last, turns into iron. Each rung demands a higher temperature and offers less time. Hydrogen burning can last billions of years. Carbon burning might hold for only thousands. Oxygen for months. Silicon for days. The star accelerates toward its end, racing through fuels as if skimming the last pages of a long novel. Imagine slicing through such a massive star as it nears its finale. At the very center, iron, beautiful and useless to fusion. The boundary where making new nuclei consumes energy instead of releasing it. Around that iron heart, a shell where silicon is burning. Beyond it, oxygen, then neon, then carbon, then helium, and finally hydrogen at the outermost reachable layer. A nested set of fires, each hotter and denser than the one above, each working under conditions that words find hard to hold. Nothing on Earth comes close. Even our metaphors feel thin. For a sun-like star, the layering ends earlier. Temperatures never rise enough to ignite carbon. After helium's work is done, the core will be mostly carbon and oxygen. The outer layers will keep shedding. In time, a planetary nebula will dress the space around it, delicate, colorful, brief on galactic clocks. At the center, the white dwarf will remain, a crystallizing core, small as a world, heavy as a star's memory, cooling with slow dignity. Even there, modest though it seems, the materials matter. The carbon and oxygen will be folded into the galaxy's pantry, ready for recipes not yet tried. The physics underneath the pageantry stays simple at heart. Gravity is patient and relentless. Energy is the only counterweight. When fuel is abundant, the outward push from fusion keeps the inward pull at bay. As fuel thins, gravity eats the slack. Squeeze raises temperature. Temperature unlocks new fusions. New fusions push back. When no fusion remains that can pay its own energy bill, the star has to choose a final state: gentle ember for the lightweights, spectacular collapse for the giants. Either way, the elements are sent onward. Watch a red giant, and you're watching the universe breathe out. Winds lift dust into space. Shells expand in transparent layers. Light reddens and deepens. Those winds seed future nurseries. Those shells cool into grains that will one day become the cores of pebbles and the hearts of comets. Inside a collapsing cloud, those grains will shade fragile beginnings from harsh light. The circle closes and opens again. The view from here this night, this room is wonderfully calm. Betelgeuse glows with its soft warning. Antares warms the tale of Scorpius. They're not threats, they're reminders. Our sun carries the same instructions inside it, patiently unread today, patiently waiting their turn. The quiet star that kept winter and summer in balance will one day become a vast red lantern, then a thin shell of color around a white coal, then a cooling ember hidden by time. Between those states, it will be generous. The elements you and I rely on will be given back. Inside any aging star, the structure is a lesson in inevitability turned into music. Helium lights when the core is hot enough around the 100 million degree mark. 3 helium nuclei become carbon. Add one more and oxygen appears. In heavier hearts, steps continue. Carbon to neon and magnesium. Oxygen to silicon and sulfur. Silicon to iron. Each layer ignites closer to the center. Each ring burns faster than the last. The timeline collapses as the temperature rises. What took billions of years at the beginning shrinks to thousands, then months, then days. It feels like watching a tree rush through its seasons. But the tree is the size of a star, and the leaves are elements. For smaller red dwarfs, patience rules differently. They sip their fuel and stir their interiors so thoroughly that no central ash builds up in the same way, and their main sequence calm can last for trillions of years. None has grown old enough for us to see its final pages. For stars like the sun, the outline is clear. The long middle yields to a warm, swollen elderhood. The core learns helium. The outer layers drift away. The remnant cools. For the giants, the onion grows to iron, and then meets a threshold the universe can't finesse. Past iron, fusion costs more than it pays. Gravity wins outright, and the ending is a collapse that rings the galaxy with light. If there's a single feeling that fits these chapters, it might be bittersweet awe. The lights we trust will change. The worlds we know will pass. But nothing vanishes into nothing. What was warmed and shaped returns to the wide, dark, as better material than it left. New stars will use it. New planets will try their chances. Perhaps new minds will sit under new dawns and talk softly about old stars, the way we are doing now. So when you catch the red of Betelgeuse or the steady ember of Antares, read them kindly. They are the gentle roar of time made visible. They are telling us the future of our own sun without urgency or threat, just certainty. They show how even the quietest stars hold the power to end stories and to start them, keeping the great rhythm that turns dust into light and back again, forever unhurried, forever at work. The layers inside a star stay hidden, but their fingerprints are everywhere. As new fuels catch and old ones fade, the surface swells and settles, brightness drifts, the color tilts warmer, then steadies again. Gentle pulsations pass through the star like a slow heartbeat, and strong winds lift its outer skin into space grain by grain. Through a patient lens, those ripples in light become a stethoscope. From small brightenings and soft dimmings, astronomers read the deep interior. The cosmos is quiet, but it leaves clues for anyone willing to listen a long time. The engine behind this layering is simple enough to whisper. When one fuel wanes, gravity tightens its grip. Tighter means hotter. Hotter wakes the next reaction. But each rung on that ladder buys less time. The energy from new fuels comes at a higher cost, and the stages grow shorter. A star that once lived by patience begins to hurry, burning through options like pages turned faster near the end of a book. Nothing here is frantic. Everything is inevitable. What follows from that inevitability is the part that touches us. Every element heavier than helium, carbon in pencil and diamond, oxygen in breath and wave, magnesium tucked in leaf green chlorophyll, silicon in sand, and circuits owed its birth to a star's layered work. Without those shells, the universe would be mostly a pale blend of hydrogen and helium, thin on possibilities. With them, chemistry learns to sing. From the outside, the grandeur can feel unreal. A star can swell so large its light envelopes planets. Its glow can outshine tens of thousands of suns. Yet even that radiance is a balance on a knife's edge, held up by thin, hot shells that will run out. The star is living on borrowed time, propped by fires that cannot last. When the final fuel fails, the path splits by mass. The lightweights loosen their hold, let their outer layers drift into space, and settle as white dwarfs. The heavyweights gather themselves, then lose the tug-of-war in a single moment and fall inward toward a supernova. Before the ending, though, the interior remains a masterpiece. Nested furnaces stacked like the rings of a living tree, each ring marking a season of burning. You can imagine that interior as a clock that counts down by elements: hydrogen to helium, helium to carbon, carbon to oxygen, onward, step by step, as heat allows. Each ring is a line on the clock face. Each new ignition is a hand moving forward. It is change, yes, but also provision. In those layers, the universe stocks its pantry for worlds that do not yet exist. When you breathe, a star's layering is in your lungs. When you gaze at quartz or watch a wave burst white, you are seeing what stellar shells once made and then let go. The aging star becomes a sculptor, shaping matter for futures far from its light. In the end, it does not fall silent. It leaves a room furnished. Most stars do not close their story with a shout. They slip into softness, trading blaze for ember. For sun-like stars and the countless red and orange dwarfs, the last act is not an explosion, but a long exhale. Hydrogen burned long ago. Helium had its turn, and made carbon and oxygen. The fires needed for anything heavier never start. Gravity steps forward. The core falls inward, until something unfamiliar to daily life says no. Electrons, crowded so tightly they cannot share the same states, push back. That quantum resistance electron degeneracy pressure halts the collapse and leaves behind a white dwarf, a core the size of Earth, holding a mass like a star's memory. A spoonful of that matter would weigh tons. The world has no analogy for that firmness. At first, the white dwarf shines with stored heat, bright and blue-white at the surface, but it has no engine now, only a glow that fades. It cools slowly, so slowly that the universe itself is not old enough to show us the end. No true black dwarf has had time to form. All the embers we see still hold warmth, drifting down the spectrum from white to yellow to red, over eras that make history seem brief. Planets, if any remain, would find their days fall into a thin, sharp light, like a point of frost lamp in a deep, cold dusk. Oceans would seal over, air would sink, the system would become an archive, a cabinet of frozen orbits around a small diamond of heat, and still there is beauty. The light of a white dwarf is clean and quiet, a cosmic coal shining with the last of its stored fire. These remnants keep records. Many white dwarfs are plain carbon oxygen, the ashes of helium's work. Some are mostly helium. A few, born from heavier parents, hold neon and magnesium in their depths. Read their spectra, and you can reconstruct the chapters that came before. The way an archaeologist reads a shard. They also face a boundary. Stack too much mass in the collapsing core, more than about 1.4 times the Sun and electron degeneracy can't hold. That limit, the Chandrasekhar limit, is the line between a star that ends gently and a star that falls further into a neutron star or black hole. Below the line, quiet embers. Above it, drama. The universe loves both humility and spectacle, and makes room for each. Our sun will join the quiet ones. After its red giant elderhood and its veils of glowing gas, it will leave a white dwarf at the center, small and brilliant, cooling with long patience. Long after Earth is a memory and our maps are dust, that remnant will still be dimming. A soft bracket around a story that once included oceans and birdsong and mines. Red dwarfs, the most numerous of stars, stretch this patience beyond our reckoning. They burn so slowly that none has reached the end yet. The cosmos is too young. Trillions of years from now, when grander suns have come and gone, they will still be giving off their faint warmth. In their far future, they too will leave white dwarfs, filling the dark with a quiet archipelago of embers. Even endings borrow a little thunder now and then. In a few close pairs, a white dwarf can sip matter from a companion. If it gathers enough to cross that Chandrasekhar boundary, it can ignite in a type Ia supernova, brilliant, even-handed in its light, useful as a yardstick for distances. A last sudden gift of brightness, and more elements scattered into the dark. But most white dwarfs never flare. They rest, they cool, they let time do its long work. There's calm, not tragedy, in that slow dimming. A white dwarf is a life that has given all it could, that forged and warmed and then folded its hands. The night sky holds many such quiets. They don't announce themselves like Betelgeuse or draw myth to their color. They are the soft punctuation marks that tell you the sentence is finished and still meaningful. Beyond them, in another corridor of fate, live the massive stars and their final barrier. They burn through shells at a dizzying pace, carbon in thousands of years, oxygen in months, silicon in days, until the center becomes iron. Iron does not pay energy back when fused, it takes it. That is the stop sign. When the core is iron, fusion can no longer counter gravity. In a breathless instant, the balance breaks, and the star begins to fall into itself. What happens next is the loudest chapter many galaxies hear, but even that shout carries the same old theme: from order to change, from change to gift, from gift to the next beginning. Think again of the onion hidden under a star's glow. Each layer is a workshop. Hydrogen shell, helium shell, deeper fires if the mass permits, each making something new and passing it on. Without those rooms, there would be less for planets to build with, less for oceans to dissolve, less for bodies to borrow. With them, the universe becomes intricate. The next time a star looks like a simple point, let your mind step inside. Picture the nested shells, the thin balance, the slow tap of a clock that measures by elements. Stars are not just shining spheres. They are layered stories. Each shell a chapter, each element a word. Together they write the long, patient narrative that turns darkness into light and back again. leaving the world richer every time the page is turned. Gravity has been patient for a very long time. Then, in the final instant, patience ends. The iron heart of a massive star has nothing left to give. Fusion cannot pay the energy bill anymore. In a fraction of a second, the core caves in, shrinking with a speed that escapes ordinary language. Electrons are pressed into protons. Protons and electrons become neutrons. A flood of neutrinos slips outward through the star, like ghosts that can walk through walls. The outer layers, suddenly without support, fall inward and crash against the new, hard core. In that collision, the whole structure tears, and the star becomes a supernova, a moment so fierce that calling it an explosion feels too small. For an instant, more energy pours out than our sun will give over 10 billion years. The light can rival a whole galaxy. From far away, it looks like a new star has appeared where there was none. A bright messenger in a familiar pattern of constellations. Ancient watchers drew it into their chronicles without knowing what it was, only that the sky had spoken with unusual clarity. Underneath the spectacle, making and unmaking proceed together. Shock waves and heat rising to billions of degrees forge heavy elements that ordinary stellar burning cannot. Gold and platinum, uranium and lanthanides, iron in quantities that will later fill the blood of creatures who haven't yet been imagined. When the star finally rips itself apart, those elements are thrown into space, like seeds, tossed by a wind that knows every field. The afterglow does not hurry. The ejected gas and dust expand and cool into luminous veils, threads, and shells supernova remnants that survive for thousands of years. Through a telescope, the Crab Nebula looks like a tangle of silk in electric color, each hue tracing a different piece of chemistry. Oxygen here, sulfur there, hydrogen in a soft haze between. They are beautiful in their own right and useful besides. Those clouds are tomorrow's seed stock. They will drift, mix with colder material, and one day gather again. The next generation of stars will take shape from this bright wreckage, and around them, if the balance is kind, planets will coalesce. At the core of the chaos, something compact and strange remains. If the collapsing center is light enough, the crush ends with neutrons packed shoulder to shoulder. The result is a neutron star, only about 20 kilometers across, and yet heavier than the Sunday. A spoonful of that matter would weigh billions of tons. If the core is heavier still, even neutron pressure cannot stand. Gravity takes the final word, and the remnant becomes a black hole, a region where space-time dips so steeply that light itself cannot climb out. Either way, the death of a giant writes an epilogue in bold letters and leaves behind an object that bends the rules we learned in quieter rooms. Supernovae feel rare from our back porch, but the galaxy sees them as part of its normal seasons, likely one every century or so in the Milky Way. Many more in other galaxies, if you have a big enough eye to watch. Dust and distance often hide them from us. Powerful surveys catch their quick brightenings and slow fades, turning what looks like randomness into a pattern. In the ecology of galaxies, they are essential. Shock fronts from these blasts ram through interstellar gas, stir it, compress it, and tip quiet regions into collapse. Without that nudge, clouds might drift half asleep for ages. With it, new stars wake. Destruction and creation share the same rhythm, different beats in the same song. From here, the strength involved is difficult to hold. If a core collapse supernova went off within 30 light-years, the radiation could strip our air and scour the ground. But the cosmos is generous with distance. Massive stars are rare, and none nearby sit in a position to threaten us. We get the light without the harm, a fireworks show watched from a very safe hill. To study one of these blasts is to study both a last breath and a first inhale. The star has failed at resisting gravity. At the same time, it has guaranteed that matter will not stay locked in stars forever. Without these endings, chemistry would stall at hydrogen and helium. With them, the periodic table fills in its squares, and worlds complicated enough to think about stars become possible. The violence is real, so is the poetry. After millions of years of burning, a giant does not simply dim and disappear. It gives a single brilliant gift, and that gift scatters across time. The metal in a ring, the oxygen in a lung, the iron that carries breath in blood. Somewhere tonight in Orion or Scorpius or a less famous patch of sky, a massive star is nearing the line. It looks quiet, a clean point among others. Inside, shells are burning fast, carbon in millennia, oxygen in months, silicon in days, while the iron core grows heavy. One night, whether tomorrow or 1,000 years from now, its light will flare so much that even a casual glance will catch it. A sudden, bright sentence added to a familiar paragraph. The universe has a way of recycling with style. And sometimes the drama continues after the blast. The core that did not become a black hole, the one that found a new balance as a neutron star, is odd enough to feel imaginary and yet perfectly real. Think of a city pressed into a sugar cube. Think of a mountain into a thimble. The surface gravity is so intense that a 1-meter drop would drive an object to a speed near light's. Magnetic fields can reach trillions of times Earth's, strong enough to whip particles into near-light motion and bend the path of light itself. Matter is forced into states that don't exist anywhere else. A crust of super-dense nuclei, deeper layers where neutrons flow as a superfluid, frictionless, ghostly, and perhaps a core where even neutrons give way to quarks. The constituents beneath, neutron stars, spin. As the collapsing core shrank, it conserved angular momentum, so rotation sped up like a skater, pulling in their arms and turning faster. Some of these stars rotate dozens of times each second. Some whirl hundreds or even thousands of times per second. Their magnetic poles funnel radiation into narrow beams that sweep space as they spin. When one of those beams crosses Earth, we hear a pulse in radio or see a flicker in X-rays precise enough to keep time by. The first detections in the 1,960 seconds were so regular that a playful label, LGM for Little Green Men, briefly floated among the researchers. The truth turned out more astonishing than fiction. Nature had built its own lighthouse clocks, and their ticks can rival the steadiness of atomic standards. On the surface of such a star, mountains can rise only millimeters before gravity forces them flat. The crust may be stronger than steel, and yet crack in sudden starquakes that change the spin by a tiny amount. Below, superfluid neutrons can store angular momentum, and then, in a moment, transfer it to the crust, a glitch making the pulses arrive a breath earlier than before. Even the missteps of these clocks are informative. They are laboratories, where the universe lets us test how matter behaves when the usual categories fail. Neutron stars do not live alone. Some orbit regular stars and sip from them, stealing gas that spirals into a hot accretion disk and flares in X-rays. Others pair with another neutron star, circling for eons, and slowly losing energy to gravitational waves, ripples in space-time that we can now feel with delicate detectors on Earth. When the pair finally merges, the impact releases a kilonova, a burst of light, richer in reds and near-infrared than ordinary supernovae. accompanied by the forging of the heaviest elements. In those brief hours, gold and platinum are minted in quantities that make human treasure small. The ring on a finger, the contacts in a phone, the circuits in a telescope, many trace their origin to the collision of two dead stars, far away and long ago. These pulses, steady and far-reaching, can guide as well as amaze. Because their timing is so precise, a spacecraft can use them the way we use GPS, triangulating position from the arrival times of several pulsar signals. That means the heartbeat of a star that died millions of years ago can help a human machine find its way in the dark. A practical kindness from something that never intended kindness at all. Seen through a big radio dish or an X-ray eye, a neutron star isn't showy. It appears as a thin, regular blink, a faint point in images. That's part of its charm. The spectacular part came earlier, when the supernova wrote its light across the sky. What remains is the echo, a metronome keeping time, violent in origin, orderly in habit, alien in substance, familiar in rhythm. A paradox you can rest your head against. Their fates diverge with their environments. Some spin down slowly, shedding energy as winds and radiation, growing quieter across millions of years until their beams fade beyond our instruments. Some feed from companions and flare with fresh brightness. Some collide and make waves we can hear across the fabric of space-time. All of them keep shaping their surroundings, accelerating particles, carving arcs, leaving rings of shocked gas, and mixing heavy elements into the medium that will eventually become new stars. There is comfort in how this all fits together. The loudest ending hands off to the quietest clock. The elements strewn by the blast settle into clouds, and in those clouds, dust shades fragile beginnings until they are strong enough to light themselves. Gravity pulls, fusion pushes, neutrinos whisper through matter, magnetic fields sketch invisible paths, pulses cross the dark with punctual grace. No part stands alone. The cosmos works in loops that look like lines close up, in chapters that are endings from one angle and introductions from another. If you step outside and look toward Orion on a clear night, Betelgeuse glows with a warm, unsteady red, the sign of a giant in late chapters. Somewhere you can't point to specifically, a massive star is moving through the last weeks or centuries of its life, and I blink either way. One night its light may arrive all at once, brighter than you expect. It will not be near enough to harm, only near enough to remind. A flare, then a fade. In the fading, a nebula will begin to breathe outward. Supernovae are not merely spectacles to be logged. They are the cosmos keeping its books balanced. Matter does not remain a prisoner of stars. It circulates heated, shaped, flung out, cooled, gathered, warmed again. Without the death of giants, there would be no earth to stand on, no water to drink, no breath to draw, no thought to think about any of this. The bang is brief, the generosity is long, and in the lingering afterglow, the remnants keep speaking. Neutron stars tick, pulsars point the way, black holes curve the paths of light and time. The night returns to quiet, but it is not the same quiet as before. It is richer. Somewhere in that richness, the atoms from an old blast are learning a new arrangement in a rock, in a cloud, in a leaf, in a living hand. The universe does not file endings under finished. It files them under changed, and then it waits, patient as gravity, for the next light to begin. Some endings arrive with trumpet and flare. A supernova bright enough to rival a galaxy. A kilonova, tossing gold through the dark, a pulsar ticking like a cosmic metronome. Another fate is quieter and more final. It begins in the heavy heart of a giant star that burned too fast for too long. Fuel steps down its ladder, hydrogen to helium, helium to carbon, carbon to oxygen and silicon, until iron sits in the center like a period at the end of a sentence. Iron takes more energy to fuse than it gives. The furnace falters. Gravity, which had waited without complaint, steps forward. The fall is swift. In less than a second, the iron core implodes. Electrons are pressed into protons, turning them into neutrons, and a storm of neutrinos escapes, skimming outward through matter as if it were mist. If the core is light enough, the crush halts on the strange solidity of nuclear density, and a neutron star is born. If it is heavier still, no known pressure can stand. The collapse passes the limits of matter and curves into a singularity. Around that hidden point forms an event horizon, the silent threshold, where paths only go inward. A black hole has arrived. From the outside, the moment is violent, while the result is mute. The star's outer layers crash, rebound, tear free. Debris lights the sky. The newborn black hole, by contrast, does not shine. It has no surface to glow, no shell to shed. It simply exists, rewriting the local rules. The horizon is not a wall, but a boundary in the map of space-time. Cross it, and return becomes impossible. Even light, the swiftest thing there is, cannot turn back. Near the horizon, time and space trade habits. Clocks run strangely. To a distant watcher, anything falling in seems to slow, its light stretched redder and redder until it fades. To the thing falling, nothing special marks the crossing, only a steady deepening of the downward path. Inside, our equations lose their footing. We can write symbols for density and curvature that run to infinity, but the picture escapes ordinary language. It is enough, for now, to say that gravity has found its complete expression. Sizes vary, but nature is consistent. Some black holes hold only a few suns' worth of mass, the remnants of single stars. Others weigh millions or billions of suns and sit quietly at galactic centers, steering the motion of stars and gas with a field too smooth to feel up close and too strong to ignore at scale. How those giants first formed is still an open story, but their presence shapes the lives of galaxies. They regulate star birth with outflows. They stir and heat. They anchor and align. The name invites a misunderstanding. Black holes do not slurp everything nearby like drains in a bathtub. At a safe distance, you could orbit one as you would any massive object. The danger lies only in getting too close. There, tides can tear apart stars. There, matter can be stretched into streamers of light. When gas does fall in, it rarely goes straight. It forms an accretion disk, flattening and heating as it spirals inward. Friction and magnetic fields whip the gas into X-ray brilliance. Jets spear from the poles, reaching across light years. The surroundings of a black hole can be among the brightest regions in the universe. Paradox is the rule. Darkness at the center, radiance in the approach. Left alone, a black hole endures. It holds what it has and changes only slowly. In theory, it leaks, very gently, by a quantum effect called Hawking radiation, pairs of virtual particles becoming real near the horizon so that one falls in and the other escapes. For black holes made by stars, that evaporation would take far longer than the universe has yet lived. They are, for practical purposes, patient monuments. We find them by inference. A star whirls around an empty point. A high, hard beam of X-rays flickers from a place without a star. A ring of fire circles, a dark disk in a distant galaxy. These are the signatures. Dozens have been traced in our own Milky Way, and likely millions more cross the dark unseen. Each one the final signature of a star's life, written into the geometry of space. There is humility in the thought that gravity alone, no exotic ingredient, only the pull that lifts tides and drops apples can, given enough mass and time, create something that silences light. The same law that shapes a child's jump rope traces the edge of a black hole's horizon. That unity feels like a kindness. The universe does not need new rules to be strange. Black holes carry the cool, deep fascination of myth. And still they are not monsters. They are part of a larger cadence, where one star ends in silence, another begins nearby, in a cloud stirred by a blast. Where one horizon swallows light, a jet paints the interstellar medium with energy. Galaxies grow around their central giants, their histories braided with the feeding and fasting of the hidden mass at their cores. Quiet power lives alongside noisy creation. Step back, and the story returns to us. Every breath you take is tied to these distant endings and beginnings. The iron riding inside your hemoglobin joins oxygen for a few heartbeats, lets it go, and repeats iron made in the last labor of massive stars. Carbon forms the backbone of your molecules, building spirals and sheets and rings. It began as 3 helium nuclei, meeting in the core of a red giant, helped by a fortunate resonance that lets the universe favor complexity. Oxygen, poured out by aging stars and scattered by their deaths, now fills lungs and seas. Silicon from stellar interiors became quartz underfoot and mines tools in microchips. Calcium, from dying stars, holds up your bones. Even the trace metals that flicker in small, essential processes, zinc, copper, iodine, crossed the dark inside dust grains before they were folded into a planet, and then into you. At the beginning, things were spare. After the Big Bang, the universe was mostly hydrogen and helium, with a little lithium, thin and simple. Left to itself, it would have stayed that way, a quiet fog. Stars changed the script. They lit fusion and turned simplicity into variety. They breathed out their first products. They died and threw their heavier ash into space. Collisions of neutron stars minted the hardest to make elements, including the gold we slip onto fingers and the platinum hidden in circuits. Each cycle, cloud to cloud again, added detail. Planets took shape from enriched dust, oceans condensed, air learned blue, chemistry grew gardens and thoughts. Your body is a ledger of those cycles. The carbon in DNA remembers the warm center of a long-vanished star. The oxygen in your next inhale remembers a shockwave. The iron in your next exhale will remember a heartbeat. To list the parts of you is to read the periodic table as memoir. The sun, calm as it seems, is writing future chapters. Deep inside, hydrogen becomes helium and keeps our world temperate. In ages to come, it will redden and loosen, then let go of its outer layers in beautiful shells, returning carbon and oxygen to the galactic commons. Those atoms will drift, cool, settle into a new cloud. The cloud will learn, spin, and collapse to a disk. In that disk, dust will kiss dust and grow to pebbles and seeds. A new star will ignite. Around it, new worlds will try their weather. Somewhere, a hand will lift a cup to light, and the loop will feel like a line from that vantage too. Recycling is the plain word. It misses the tenderness. Matter is not merely reused, it is reimagined. A carbon atom that once flared in a star now links two bases in a strand of DNA guiding the building of a cell. An oxygen atom once trapped in a hot shell now joins two hydrogens to make water in a cloud, then later runs in a river, and later still finds its way into a leaf and into a lung. Calcium scattered from a dying giant now carries the weight of a step. Every part of you is a long traveler. The black hole sits in this tale as an anchor, not a full stop. It is where gravity demonstrates the end of one path and opens a different kind of persistence. Invisible, unreflective, and yet present the quietest of graves, the strongest of markers. Galaxies organize around their largest examples. Smaller ones roam like punctuation, turning up in pairs and triples in the outskirts of starfields. When two black holes meet, they braid space and time into waves that ring across the universe. We can now hear those rings with careful instruments. Another way endings announce themselves. Look up on a clear night and most of what you see is starlight. Somewhere in that field, though you cannot point to them, are the horizons, where light ends. They do not twinkle, they do not paint the eye. They are stitched into the fabric that holds the rest. It is strange comfort. Stars die, their remnants endure, their gifts spread. Gravity writes the last line of one chapter and hands the book to chemistry for the next. Hold this in mind as gently as you can. You are not separate from these processes. You are one of their outcomes. The warmth on your face in the morning began as a photon born deep in the sun and took hundreds of thousands of years to find the surface, then crossed space in 8 minutes to arrive at your skin. The breath you draw now bears atoms that passed through supernovas before there was an Earth to catch them. The thought moving softly through your head is structured by molecules that remember the fires of other skies. Black holes, then, are not only symbols of endings. They mark the range of what gravity can do and remind us that the universe has room for silence as well as song. They are the dark punctuation between bright sentences, and the text goes on. Somewhere, light is starting inside a cloud. Somewhere, a jet is tracing the spine of a galaxy. Somewhere, an old star is loosening its hold and letting its elements go. The story's tone is patient. Its meaning is generous. Stand at a window at night and breathe. The same laws that hold you to the floor bind the moon and curve the path of a comet and pull a dying star into a horizon no light can cross. The same elements that once lit a nebula now move through your blood. The abyss is part of the family. It holds what must be held, and because it holds, other places can shine. Continuity can feel like a hand on the shoulder. Stars end, yet they do not vanish. Their matter lingers, altered and set free, drifting into clouds that will one day brighten again. Life belongs to this flow. It isn't an exception to the cosmos. It's one of its natural habits. To be here at all is to be threaded into the long fabric of stellar work. Let that widen the sense of home. We aren't spectators outside a glass dome. We are made of the dome, the dark, the light, the dust that learned how to think. When you look up, you're not only seeing other suns, you're seeing the ingredients of yourself, sent across time. Starlight isn't just pretty, it is a reminder that matter and meaning can share the same breath. Pause for a slow inhale, the oxygen that helps your chest rise once hid in a star's heart. Listen to your pulse. Its rhythm depends on iron that first took shape in a dying giant. Set a palm against the ground. The calcium that holds you upright came from explosions long before Earth cooled. These aren't metaphors. They are precise truths, written in your blood and bone. Stars give more than brightness. They give substance. Mountains lift because heavy elements exist. Rivers wander because minerals and air can interact. Forests grow because sunlight and carbon learned a delicate dance. Animals breathe because stars spent themselves and left behind what lungs require. Even the act of wondering, this quiet curiosity, depends on atoms arranged by stellar furnaces and scattered by stellar endings. They are patient architects, building a universe capable of looking back at itself. Every atom in you is a small archive. Every breath and step is a continuation, not a departure. The stars may seem far, but they are as close as your skin and thoughts. You are not apart from them. You are their latest chapter. The cosmos does not only destroy, it keeps creating, even in its endings. People felt this long before they knew the physics. For as long as necks have tilted to the night, stars have been kin and compass. Before lenses revealed plasma and fusion, humans mapped meaning. Stories climbed the sky and stayed there. The science tells how stars live and die. Imagination gives the sky a second illumination. Cultural, tender, human. Across the Nile, stones were set to greet a star. Temples and pyramids faced specific risings, especially Sirius, whose dawn appearance foretold the river's flood. Water would come, fields would wake, life would lift its head. Sirius was not just a point of light, but a promise dressed in the language of the gods. In Greece, the heavens filled with heroes and their trials. Orion walked there with his dogs. Perseus and Andromeda held a story's tension from horizon to horizon. Myth preserved values in the same sky that preserved chemistry. Courage marked in stars as surely as carbon is marked in you. Far to the east, another sky took form, hundreds of asterisms in Chinese tradition. A careful mirror of palaces and markets, rivers and roads. Court astronomers kept watch, not just for cycles, but for messages. A sudden star, what we call a supernova, could be read as a warning or a sign that the balance of rule had shifted. The sky was a book with margins full of notes. In the wide Pacific, the night became a map. Polynesian navigators memorized risings and settings, felt swell and wind, and used stars as waypoints across open water. Canoes crossed vast distances on the strength of memory and the trust that a star keeps its place. Those paths stitched islands together long before a compass needle spun. Elsewhere, the lights gathered into patterns of fate. Babylonian charts followed the motions of planets and assigned meaning to their arrangements. The belief that positions overhead could hint at fortunes below traveled forward through centuries as astrology. Not science, but a persistent sign of how deeply humans wanted their lives braided to the sky's order. Across continents, indigenous knowledge made its own constellations. The Lakota spoke of star people. Songs and stories folded the night into ceremonies and directions. Aboriginal Australians read the dark between stars, the emu traced not in points, but in the Milky Way's dust lanes. These stories held calendars within them, guides to seasons, migration, harvest, and care. Myth carried instructions for survival. What repeats through all of this is simple. Every culture found itself reflected up there. Guardians, judges, companions, teachers. Falling stars became wishes. Bright omens became warnings or blessings. The sky is too steady to ignore and too large to leave empty. Filling it with meaning was as inevitable as sunrise. Science later untied the knots and showed the threads. No divine fire, no fixed fates, but natural things obeying consistent rules. Knowing didn't empty the wonder, it deepened it. To learn that the light from Orion's belt started toward us 1,000 years ago is not to lose magic, it is to gain time. To learn that the carbon in your cells was made in a red giant's core is to be handed a lineage older than any story and tenderer than most. Stars may no longer be gods, but they are still sacred sources, not symbols only. They remain badges of belonging today. Flags borrow their shapes. Musicians and poets borrow their names. Astronauts sight-check by them. Reach for the stars is still how we talk about hope that outruns habit. What makes them so strong for us, perhaps, is their double nature. Constant and changing, near in meaning and far in reach. Ordinary to the eye and extraordinary in truth. They balance familiarity with mystery, which is exactly the balance that keeps a mind awake. So their legacy is not just physical atoms and minerals and air, but cultural stories and maps and rituals. The night is noisy with old voices if you know how to listen. And yet, all that meaning fits inside a simple fact. Stars are real. They burn. They age. They return what they have made. Those truths do not cancel the myths. They sit beside them, and the pair feels more human than either alone. When a star finishes, whether as a quiet ember or a violent blossom, nothing is wasted. It gives itself back. Gases and grains move out into the interstellar medium, mixing with the thin sea of hydrogen that fills the galactic lanes. That's where new stars take shape, in clouds nudged by shock waves or gently compressed under their own weight. Endings become the next beginnings. The sky holds the record. Most of the lights you see tonight are not first children. They are second and third generations, made from matter that has already been through a furnace and back. Look at any one of them, and you are seeing a memory of older stars, written in new form. The cycle is straightforward. Return, gather, ignite, shine, return again. For the smaller stars, the return is a sigh. As they swell into red giants, their skins loosen and drift into space. The inner ember lights that gas from within, and for a short while, a planetary nebula glows a ring or shell in greens and reds through a telescope, delicate as breath in winter air. Carbon and nitrogen and oxygen spread outward, ready to be woven into new places, soft farewells with practical gifts. For the massive stars, the return is a shout. The supernova hurls metals and gas at high speeds. The shock front sweeps through neighboring clouds. Where it passes, it compresses. Where it compresses, gravity can take over. The death of one can trigger the birth of many. Midwife by blast, nursery by aftermath. The Crab Nebula is a snapshot mid-breath, 1,000-year-old echo, still expanding, still shining, still mixing its colors into the larger sea. In truth, almost every star-forming cloud is a patchwork of inheritances. The Orion Nebula is a bright example, pillars and folds and hollows, all of them enriched by previous lives. In those folds, new stars are taking hold. Around some of them, disks will flatten. In some disks, pebbles will grow to mountains, and mountains to worlds. Perhaps, on one of those worlds, something will crawl, then walk, then watch the sky and ask where it came from, and the answer will be short and exact, from the ashes of older stars. This is not just poetic structure, it is the skeleton of complexity. Without enrichment, the universe would still be mostly hydrogen and helium, beautiful, simple, and quiet. With it, chemistry has room to play. Carbon builds long chains and tight rings. Silicon forms the scaffolding of minerals. Iron sinks into planetary cores and helps hold magnetic fields. Phosphorus snaps into DNA. Calcium stiffens bone. None of it appears without the long habit of stars making and unmaking. The galaxy wears the process like weather. Regions busy with new stars glow blue and silver, light reflecting off dust like a soft echo. Old neighborhoods where gas is thin and calm hold redder, older stars and a slower sky. Between those zones, filaments connect, gas moving, dust drifting, gravity gathering with the patience of a tide. Even the quietest truths are personal when you let them be. The continuity you're part of is not only out there, it's here, in this breath, in this small, steady heartbeat. In the way calcium lets you stand, and iron lets you carry air through your body. In the way carbon holds your thoughts together, and oxygen gives them time. You are an expression of the sky's long patience. Your life is one more place the universe is trying out a way to understand itself. Hold that gently when you go outside at night. The stars are facts, nuclear furnaces obeying laws as simple as push and pull, as exact as numbers in an equation. They are also stories: Orion hunting, Sirius returning with the flood, the emu etched in the dark lanes of the Milky Way, a canoe steering by memory and light. They are guides and gods and bright chemistry. They are both ledger and lyric. The cycle goes on. A red giant loosens its hold and paints color into space. A supernova shouts and presses a quiet cloud into motion. A nebula gathers itself and flickers with new embers. A world forms. Water learns to reflect. A child squints at the night and gives names to patterns no one has named before. The universe is understandable and mysterious in the same breath, which might be the reason it feels like home. When you lift your eyes again, try to carry both truths. The stars are lawful. The stars are meaningful. Their light has crossed old distances to find you. Their matter has crossed old eras to be you. Continuity is not an idea pinned to a wall. It is the way everything actually moves. Even when a chapter closes with a gentle shell or a thunderous wave, the page that follows is already being written in some quiet corner of the dark. Astronomers read the sky the way a careful reader follows a long novel light, as sentences, spectra as margins, dust lanes as quiet subplots. From the soft glow of a nursery to the thin hush of an old stellar neighborhood, they can tell where the cycle is lively and where it has slowed to a thoughtful pause. Galaxies change through this constant exchange, birth feeding death, death feeding birth, each generation salting the next with new elements. Our own sun is one bead on that long thread. About 4.5 billion years ago, it gathered from a cloud already enriched by older explosions. The evidence is written into Earth itself. Isotopes in ancient rocks hint that a nearby supernova may have tossed fresh material into the very swirl that became our planets. The sun, the earth, and everything that lives here carry the inheritance of stars you will never see and names no one ever spoke. It humbles the heart to count how many endings became our beginning. Dozens, perhaps hundreds, of giants burned and broke themselves open, and their shrapnel of atoms drifted until it found this small, blue solution to the question of what matter can be. Life is the most intricate expression of that cycle. Atoms forged in heat, learning to arrange themselves into senses and memory, into patience and laughter, into a gaze that rises at night and quietly asks where it came from. This exchange keeps the cosmos from growing tired. If matter stayed locked in old stars, the bright parts of galaxies would slowly dim, their gas trapped. their clouds too thin to fall. Instead, stellar endings churn the medium between stars, stirring, compressing, and seeding it. New clouds grow heavy, new sparks catch. Individual suns are moving notes. Together they form a choir. One voice ends, the chord continues. From where we stand, this rhythm has a tender consolation. We are used to thinking of endings as empty places. Out here, they are handoffs. A star does not lose itself, it redistributes itself. Destruction is simply a different word for transformation, and even the rarest gifts find their way back into the general fund. Gold and platinum from colliding neutron stars will, in some far afternoon, gleam on a finger or run through a circuit. Uranium scattered by a supernova will warm a planet's crust and tug on its geology for ages. Beauty and usefulness travel the same roads. Nothing in this story stands alone. A star lives, warms its world, loosens its hold, and returns. The remains mingle with other remains. Gravity gathers the mix. Ignition follows. The cycle continues. Over billions of years, this stitching binds stars and worlds into one fabric. When you stand beneath the night, you aren't only seeing lights that exist now, you are seeing the relay itself. Each sun an heir and an ancestor, each glow a baton passed. Continuity may be the kindest legacy stars leave. Brilliance fades, shapes change, but the material keeps working. Life and weather and mountains and oceans are not separate from that flow. They are the flow in a certain mood. The light overhead carries the memory of generations, and the atoms that make your thoughts are part of that memory too. The science is firm and the implication is gentle. Nothing is wasted. From the first sparks after the Big Bang, the universe has been rewriting itself. A simple, quiet fog of hydrogen and helium became a place with color and chemistry, with rocks, with waves, with faces looking up. Each time a star turns on, it adds a sentence to the long text, written not with ink, but with photons and elements and time. Stars anchor galaxies, sketch the scaffolding of planets, and, invisibly, become ancestors to minds. Most of this work is not dramatic. A typical star keeps a patient balance for eons, gravity leaning in, fusion leaning out, the two in a durable handshake. That steadiness is a gift rare enough to build a world upon. Seasons that keep their rhythm, oceans that hold liquid, a climate that allows complexity to learn its steps. Our sun is unremarkable on paper and extraordinary in practice. It is neither mighty nor immortal, and yet from its patient glow came tide and fern and city and song. The tempo of a star's life plays beyond the beat we keep. Clouds gather with the slowness of snow. Protostars warm by inches. Main sequence years stack like quiet stones. Aging comes like a long, deepening breath. Even their endings, embers or lanterns or thunderclaps, serve the rhythm of renewal. A white dwarf cools and returns its light to the background. A red giant sighs its layers into space. A supernova flings a billion small gifts into the dark. Each gesture funds a beginning elsewhere. In doing this, stars act as alchemists who never hoard. Carbon for cells, silicon for stone, iron for cores and blood, oxygen for lungs and seas, all forged, then freed. The elements drift, swirl into clouds, and collapse again. Nothing is lost between the lines. If you trace any atom in your body backward, you will pass through a nebula, through a dying sun, through a patient cloud, and you will eventually arrive in a furnace that never knew your name. and made you anyway. Look at a faint nebula, there a cradle waits. Look at a white dwarf, there a memory rests. Look at a black hole, their gravity has finished a sentence and left a period in the shape of a horizon. Every point of light belongs to this single story. Some just opened their first page, others long ago turned the last. The whole reads as one, past, stitched to future. And because we are human, the story wears two faces at once. Stars are objects, natural, lawful, measurable. They are also symbols, guides, gods, emus drawn in darkness, hunters strung along the belt of night, sailors crossed by their coordinates, farmers planted by their risings. Children wish on their brief sparks, knowing the physics does not empty the myth, it frames it. The idea that a hunter's belt is 3 distant suns does not erase the hunter. It adds depth to the picture, as if someone quietly pulled a new layer of canvas into view. It's easy, sitting under so much light, to feel small. The stars are far. Their clocks tick slowly. Our days are brief, yet the intimacy is real. The light just now reaching your eyes began its trip long before your morning did. The atoms in you began their travels long before there was a sun to warm them. The sky is not a stranger's face, it is family. Its steadiness offers a kind of peace. Whatever storms we live through, the larger cycles keep their pace. A star burns, a star cools, a cloud gathers. The pattern continues in a language that does not raise its voice. To think about stars is really to think about how existence keeps making room for itself. How matter learned form, how form learned memory, how memory learned curiosity. Stars tie those chapters together, past to future, chemistry to culture, fact to meaning. They are quiet engines that keep the universe lively and full of potential. Each clear night is an anthology newborn. Embers in their veils, middle-aged suns warming their worlds, elders softening toward rest, all of them part of one unbroken chain. To lift your eyes is to watch a slow theater of beginnings and endings, and to recognize, somewhere in the middle of it, your own short scene. That may be the calmest truth of all. You are not separate from what you see. Their light touches your eyes. Their atoms move in your blood. Their cycles echo in your pulse. Living is participating in their legacy, keeping time with the quiet rhythm that started when the first fires took hold. The stars feel far, but they are as near as your breath. So when evening lowers and the sky opens, pause. Let the slow light remind you of patience, of endurance, of the way creation folds endings into beginnings. Each twinkle is a message, carried across distance and years. Nothing is wasted. Everything transforms. You belong to this. Stars are not decoration. They are the reason there is a canvas to paint it all: the fire, the memory, the promise. They continue, steady and unhurried, generation after generation, building a universe capable of wonder. And as they keep shining, the story keeps writing itself softly, steadily on skin and stone and sea and sky. A rhythm gentle enough to sleep by, bright enough to wake to, always there, always moving forward in light.